Have you ever wondered why some stars in the night sky have a reddish hue? These crimson beacons are not just a spectacle to behold, but are also a treasure trove of cosmic information. They are known as carbon stars, and today we're diving deep into their life cycle to understand why they shine so red. A carbon star doesn't simply appear out of nowhere. It begins its life just like any other star, as a nebula. Nebulae are vast interstellar clouds of dust and gas where stars are born. Over countless years, the gravitational forces within these nebulae cause the dust and gas to coalesce into a protostar. This young star then spends millions to billions of years in a phase known as the main sequence, burning hydrogen at its core to produce helium. However, as the hydrogen fuel depletes, the star begins to evolve. It enters a stage known as the red giant phase, where the core contracts and the outer layers expand. The core temperature increases, triggering a new phase of nuclear fusion where helium is converted into heavier elements like carbon and oxygen. This process gives birth to a carbon star. In a carbon star, the abundance of carbon in the outer atmosphere is greater than that of oxygen. This surplus of carbon results in the formation of carbon molecules, such as carbon monoxide and other carbon compounds. These molecules absorb certain wavelengths of light, particularly in the blue and green spectrums, and re-emit them in the longer, redder wavelengths. This process gives carbon stars their distinctive red hue. But the story doesn't end here. Carbon stars are variable stars, meaning their brightness changes over time. Some pulsate in a regular pattern, growing brighter and dimmer in a predictable cycle. Others exhibit more erratic changes in luminosity, making them intriguing subjects for astronomers to study. To summarize, a carbon star begins its life as a nebula, evolves into a protostar, spends a considerable amount of time in the main sequence phase, and eventually becomes a red giant. During the red giant phase, the star produces an excess of carbon through nuclear fusion, which is then released into the outer atmosphere. This carbon absorbs and re-emits light in the red spectrum, giving the star its unique coloration. Carbon stars also display variability in brightness, adding another layer of complexity to their nature. So the next time you gaze at the night sky, spare a thought for the carbon stars. These red giants are not just beautiful to look at, but they also provide a window into the life cycle of stars and the intricate processes that take place within them. They are reminders of the ever-evolving dynamic universe we inhabit.